Hello everyone, welcome back to my YouTube channel. Myself Kirtana HR, currently pursuing in third semester in the Department of Computer Science and Engineering at Sri Venkateswara College of Engineering, Bengaluru. Today's subject is Mathematics and the subject code BCS 301. Today's presentation is on sampling distribution and standard errors. Now let us see Introduction to Sampling Distribution. Sampling distribution refers to the probability distribution of a statistic obtained from a larger population. It illustrates how the sample means vary from sample to sample. Understanding this concept is crucial for making inferences about population parameters. Importance of sampling distribution. Sampling distribution allows researchers to understand the variability of sample statistics. It is essential for hypothesis testing and confidence interval estimation. Accurate inferences can only be made when the sampling distribution is appropriately understood. Definition of standard error. Standard error is the standard deviation of the sampling distribution of a statistic. It quantifies the amount of sampling variability or dispersion. A smaller standard error indicates that the sample mean is a more accurate estimate of the population mean. Relationship between sample size and standard error. The standard error decreases as the sample size increases. Larger samples provide more information about the population, leading to reduced variability. This relationship is expressed mathematically as SE is equal to sigma divided by root of n, where SE is the standard error, sigma is the population standard deviation, and n is the sample size. We can see the formula for calculating sample standard deviation as shown in the table. Central limit theorem. The central limit theorem states that the sampling distribution of the sampling mean approaches a normal distribution as the sample size increases. This holds true regardless of the shape of the population distribution given a sufficiently large sample size. The theorem is foundational for statistical inference, allowing the use of normal distribution properties. Characteristics of sampling distribution. The mean of the sampling distribution equals the population mean. The shape of the sampling distribution becomes increasingly normal as sample size increases. Variability in the sampling distribution is quantified by the standard error. Types of sampling distributions. There are various types of sampling distributions, including those for means, proportions, and variance. Each type has its own characteristics and is used for different statistical analysis. Understanding the type of sampling distribution is key to selecting the appropriate statistical methods. Here you can see types of sampling distributions like sampling method and their descriptions and examples. Calculating standard error for means. The standard error for the sample mean is calculated using the formula, that is SE is equal to sigma divided by root of n. Here sigma represents the population standard deviation and n is the sample size. This calculation highlights how sample size directly influences the precision of the sample mean. Calculating standard error for proportions. The standard error for sample proportions can be calculated using SE is equal to root of P of 1 minus P divided by N. In this formula, P represents the sample proportions and n is the sample size. This calculation is crucial for estimating the variability in proportions estimates from sample. Confidence interval and standard error. Confidence intervals provide a range of values within which we expect the population parameter to fall. The width of the confidence interval is influenced by the standard error. Smaller standard error yield narrower intervals. Thus, understanding standard error is essential for constructing accurate confidence intervals. Hypothesis testing and standard error. Standard error plays a crucial role in hypothesis testing, particularly in calculating test statistics. It allows researchers to determine whether observed sample results are statistically significant. Hypothesis tests rely on the standard error to access the likelihood of observing data under the null hypothesis. Margin of error. The margin of error is the range within which the true population parameter is expected to lie. It is directly related to the standard error and the confidence level chosen. A larger standard error results in a larger margin of error, affecting the precision of estimates. Application of standard error in research. Researchers utilize standard error in various fields including physiology, medicine, and economics. It helps in interpreting data and making informed decisions based on sample statistics. Understanding standard error enhances the reliability of research findings. Graphical representation of sampling distribution. Sampling distributions can be visualized using histograms or bell curves. These visualizations illustrate the distribution of sample means and their variability. Graphical representations aid in comprehending the central limit theorem and standard error. Real-world examples of sampling distribution. Polling organizations use sampling distributions to estimate public opinion. Clinical trials rely on sampling distributions to determine the efficiency of treatments. Market research employs sampling distribution to analyze consumer behavior patterns. Common misconceptions. A common misconception is that the standard error is the same as the standard deviation. While they are related, standard error specifically pertains the sampling distributions. Another misconception is that a smaller sample size leads to a more accurate estimate, which is incorrect. Limitations of sampling distributions. Sampling distributions assumes random sampling, which may not always occur in practices. Non-random samples can lead to biased estimates and unreliable results. It's important to recognize these limitations when interpreting results. Conclusion on sampling distribution and standard error. Sampling distributions and standard error are foundational concepts in statistics. They provide insights into the variability and reliability of sample estimates. A solid understanding of these concepts is essential for effective statistical analysis. Thank you everyone for watching my video.